Day 515 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2221, find triangular sum of an array. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero index integer array nums where nums of I is a digit between 0 and 9 inclusive. The triangular sum of nums is the value of the only element present in nums after the following process terminates. Let nums comprise of n elements if n is equal to 1 in the process. Otherwise, create a new zero index integer array, new nums of length n minus 1. For each index I, where 0 is less than or equal to I and I is less than n minus 1, assign the value of new nums of I as nums of I plus nums of I plus 1 mod 10, where mod denotes modulo operator. Replace the array nums with new nums. Repeat the entire process starting from step 1. Return the triangular sum of nums. All right, y'all. So I can understand how that may be a little bit difficult to understand. So let's go ahead and take a look at these examples just to make sure we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, 2, 3, 4, and 5. Our output is 8. Explanation says the diagram depicts the process from which we obtain the triangular sum of the array. All right, y'all. So let's break this down one step further. So this array right here represents this first line or this base of our upside down inverted triangle, right? So as you can see, the top starts 1, 2, 3, 4, 5. Those are the elements that we get in our array. What we do want to do is we want to add these two elements to get. So we want to create rows until we get to just one element. So for the next row, we're going to add these two elements together. 1 plus 2 will give us 3, 2 plus 3 will give us 5, 3 plus 4 will give us 7, 4 plus 5 will give us 9. Now this is where it gets a little tricky, but this is where the mod 10 comes into place because 3 plus 5 equals 8, 5 plus 7 equals 12, but we just want the 2, right? There's 2 remaining after 10. When we add 5 plus 7, we get 12. That's 2 more than 10, so we put a 2 right here. Similarly, we have 7 plus 9 equals 16. That's 6 more than 10, so we put the 6 right here. Then we do 8 plus 2, that equals 10, so we put the 0 right here. And then 2 plus 6 equals 8. 0 plus 8 equals 8, and that's how we got our output of 8. So let's take a look at example 2 where they might try to throw a trick question our way where there's only one element, right? So in example 2, we have our input nums equals an array of integers that one single integer is 5. That means our output is 5. Explanation says since there's only one element in nums, the triangular sum is the value of that element itself, which is 5. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. I want y'all to make sure you stick around at the end because I have a second solution for y'all. So we're going to go through 2 different solutions for this problem. Make sure you stick around so you can understand and learn both of them. Now, for the first solution, the first thing we're going to do is we're going to create a mutable copy of the input array so we can modify it in place. So we're going to declare a variable called new nums, and we are going to set that equal, new nums, we're going to set that equal to nums. And all this is going to do is it's going to allow us to mutate nums. Boom. Then we're going to come underneath that and we need to track the current effective size of the array as we reduce it. So we're going to declare a variable, we'll call it cur size, and we'll set it equal to nums.count. Boom. Now we need to keep reducing the array until only one element remains. So we're going to say while cur size exclamation point equals, so does not equal 1, we're going to open up the brackets. And for each index up to the second to last element in the array, we're going to loop through. So we're going to say for I in 0 cur size minus 2, we're going to open up the brackets. And we're going to replace the element at index I with the sum of it in the next element, modulo 10. So we're going to say new nums, square bracket I, equals, open up the parentheses, new nums, square bracket I, come outside the square bracket, plus new nums, square bracket I plus 1, come outside the square bracket and parentheses, and we're going to say mod 10. Boom. And after 1 pass, the array has effectively shrunk by 1, so we can shrink cur size or decrement cur size by coming right here, say cur size minus equals 1. Boom. Then when only one element is left, we're going to return it as the triangular sum by coming right here. And all we have to do is say return new nums, square bracket 0. So let's go ahead and give this a run. Make sure it runs correctly before we submit it. Let's see, and it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 25 milliseconds beats 90% of users. That's what I'm talking about. That's what I like to see, y'all. So now that we did that, let's get into the second solution. And guess what, y'all? Guess what? We got a one-liner. That's right, y'all. We're able to solve this problem in just one line of code. I wanted to make sure I give y'all both solutions because they're both simple and easy to understand, and we can learn from both of them. So why not? Now, the first thing we're going to do is we're just going to check to see if nums count is greater than 1 by coming right here. We're going to say nums dot count is greater than 1. Boom. Now, if that is true, so we're going to say we're going to put the question mark to check if that is true or not. If that is true, then we're going to recursively call triangular sum on a new array created by combining adjacent pairs of numbers modulo 10. So we're going to say recursively call triangular sum. Sorry, y'all. Get my spelling right. Let me see, is that right? Open up the parentheses, and we are going to say 1 dot less than nums dot count. Come outside of the parentheses, we're going to say dot map. We're going to open up the brackets, then we're going to open up some more parentheses, and we're going to say nums square bracket $0 minus 1. Then we're going to come outside of the square brackets. We're going to say plus nums square bracket $0, come outside of the parentheses, but still inside the square brackets, and we're going to say mod 10. Boom. And that should be also, or actually, nope, we're not done yet because we still need to handle if this is not true. This is just how we handle it if it is true. Sorry, if it is true. Boom. So now we need to, oh, and sorry, y'all, this should be wrapped in parentheses as well. So it should be two parentheses, right? A parentheses right here, and then it should be another parentheses right here. Boom. Now, to handle the case if it is true or it's not true, then we could just say colon nums square bracket 0. So if nums dot count is equal to 1, then we could just return nums of 0. So let's go ahead and give this a run. Make sure it runs correctly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 111 milliseconds beats 10% of users. We definitely could get those numbers up, but that's why I wanted to give y'all two different solutions. You could choose whichever one you like better. But with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.